Hi, everyone. Welcome to the Biz Dev Podcast, the podcast about developing your business. I'm David Baxter, your host, and I am joined by professional Spanx model, Gary Voigt. How's it going, man?
It's going pretty good. I actually just got my contract renewed, but I'm under an NDA, so I can't really turn around and share.
But can you breathe okay with all that holding in? What you don't know is Gary's 3 times that size.
It's not my breath that it constricts, but yeah, I got to cut down on carbs, man.
He's 3 times. Those Spanx are really good. They just really suck it on in there. Anyway, more importantly, we are joined by Shahar Keinan, who is officially the CEO and co-founder of POLARISqb. So we're going to learn what all that fanciness means here in a minute. I wanted to talk about briefly. I want to start our conversation. First off, welcome. I don't do that enough. I don't welcome our guests enough, and I'm just rude and just dive on in there. So welcome. Okay. So I've done that. She smiled at me, so I'm going to count that as a win. I wanted to talk about this little thing I found on LinkedIn. It's about AI stuff because we've been talking about this, and this is what's hot. What did it say? It said, I want to get this right. I sent it to my team this morning. It said that ChatGPT 4, the newest version of OpenAI's ChatGPT AI bot thingamabobber that we've been talking about, just passed the U.S. medical license exam with flying colors. More importantly, it diagnosed a 1 in 100,000 condition in seconds. This guy says the future of medicine has changed forever. That was a LinkedIn post. So you're in this space, right? This is where you live, in the medical kind of spacey space. What does that do for you? Does that scare you? Does that excite you? Neither? What do you think?
It excites me. Technology excites me to begin with. But also, come on, we've been through enough of those hype cycles, right? So it is exciting, but unless we really understand what it does, what it doesn't do, we have to be careful there, right? We should not expect people to come to their physician tomorrow and say, I have a stage 4 terminal cancer. How come ChatGPT doesn't found something for me? Right? It is more and it is less than what we are saying it can do. Where I work for is designing new molecules. These molecules can become drugs. The process of making a molecule into a drug is 7 years, right? That's why we have all of these big pharma companies out there. They take the output of what I do or other people in biotech do, and they take those molecules and make sure that they are doing what they're supposed to do, so cure a certain disease and don't cause too much damage along the way. And that's something that at some point you can only do that by trying it on real people, suffering people, and you have to make sure that the drug that you give them cure them or lower their effects and don't cause too many side effects. And we have regulatory FDA that make sure about that, right? And we have a whole set of system to support that. Now, ChatGPT you can ask it. Should I call it an it? You can ask it a thing, right? You ask it a question, and if somebody else knows the answer to that question and put it online, it will give you the answer.
Yeah.
If you ask it something that nobody has ever asked before, or there's no information online, it will give you garbage. How do you know if it gave you garbage or not garbage? You usually will go to somebody who knows the answer and ask them, right? What would have happened if we would have asked ChatGPT something completely spurious, right? I would have asked it about some disease that I just invented. It would also have given me an answer, by the way. I've tried.
It would give you a very confident answer of absolute gibberish.
Yes. So it works in some cases. It works beautifully, amazingly. But it also, you have to know what to ask, how to ask. I don't think it's going to change. It is changing parts of the world of where we live, but it's going to take a while.
But I can totally imagine. And they actually had a television show. I'm addicted to New Amsterdam currently. And they had an episode a couple of years ago where they had a tablet that one of the doctors was carrying around, and they would hear the symptoms and complaints from the patient, and it would turn around and help the doctor diagnose. And I could totally see that changing medicine because then you've got the world's most knowledgeable doctor, right? They've read literally every medical book ever written, and that's at the fingertips of every doctor, some of which are horrible, some of which are amazing, right? So now you've got this diagnostician. Boy, I just butchered that. I just killed that. Well, the person who diagnoses it, right? That's a whole type of medicine, right? The diagnostician or whatever.
Yeah.
Dr. House.
It would really make their lives a lot better, right? You have Dr. House, who is crazy and funny in TV, but those people exist. But now you don't need a weirdo like him on the TV show. You can have all of that knowledge in a thing. Does that change medicine? I think it does in a way.
But medicine is statistics, right? Right. When you hear hoofbeats, assume it's horses and not zebras, right? That's medicine. But there are the zebras, right? So when you come to your physician and you're coughing, she will say allergies, cold, flu, and she will go down the list, right? Until at some point there's some other things there. And you are and that's what ChatGPT does as well. And maybe ChatGPT is really good at saying this is allergies because this is the right season. Maybe that thing doesn't know how to go through the lower cases, the less statistically relevant cases, because there are not so much documentation of those.
I do remember reading headlines and seeing articles about how AI is assisting with creating new sequences and proteins to help with coming up with either vaccines or other molecules. Is that something that you see working well in your industry? Or is it just a lot faster than humans in that area where it's just giving you a lot more to choose from and test?
I think it's the second option. Okay, it's faster than human, and it's giving you more things to test. The issue is, think about the difference in ChatGPT between version 3 to version 4, right? Yeah. So they added, I thought it was like 2 orders of magnitude more data in order to build the model, right? It's a model. It looks very smart, but it is, by the end of it, a machine learning. It's a model that you build. You take the data, you digest it, and then you ask questions. And the answers have to be something from the data.
Yeah.
Right. In my areas, in my field, drug design, biotech, protein design, there is a problem of not enough data. Okay. The data sets that we have are very small, thousands of molecules, which is a lot of effort put into that, but that's not a lot of data. There are places where there's much more data. Okay. For example, something that's called protein folding. What's the structure of a protein? A protein is a long molecule made out of multiple amino acids, and it folds on itself. It creates a 3-dimensional structure. What's that 3-dimensional structure? Okay. So only in the last year or so, there were models that are good enough. One of them came through Google, a folding. There's one through Meta. There's 2 groups in China. There's another group in University of Washington. And all of these groups basically have enough data, experimental data, that somebody built the model, built the protein, synthesized it, measured it, and put this into a database. And then these groups came in and looked at that database and created a model. And only in the last year, these models are accurate enough that we can start using them.
I want to back up like I always do. I feel like that's my new right, Gary? And now it's backing up. Anyway, tell me about your company, because this is ultimately a business podcast, and I want to make sure that we talk about your company and how it came to be. You're a co-founder.
Yep.
So where did this idea come from? How did you guys come to be?
So I'm a computational chemist by training, so a scientist. Worked in molecular drug design for many years. One of the things that interest me was something we think of as chemical space. What's the possibilities of connecting atoms to create molecules and make something useful out of them? Okay, like drugs. About 3.5 years ago, um, Bill Shipman, my co-founder, and myself, we were working at a different company. That company did not succeed, or succeeded for a while and then was less and less active. And we were sitting and we were trying to figure out, what do we want to do when we grow up? What kind of what didn't work before, and can we fix it? And one of the issues that we found was that the number of molecules that we can look at was not very large. Even on a really good computer, a Google Cloud, we can have access to thousands, 10,000s of nodes. We wanted to have a bigger chemical space. We wanted, because, okay, let's step back one step. Drugs, molecules, they need to do two things, right? They need to cure you, and they need to not kill you at the same time. Okay, that's what you want from a drug.
Fair.
The cure part is usually bind to a protein, a machine in the body, and either make it work more or work less. Right? That's how most of the drug works. They bind to a machinery in your body or in a virus body, and either stop it or make it work better. Right? If it's in cancer, you want to stop replication of the cancer cells. Right? So you find a protein in the body that replicates the cell, and you stop that replication. Okay. Maybe you have a heart problem. Some machinery doesn't bring something into your cell. You want that machinery, that protein, to work more, to bring that nutrient to the cell more. Okay. So these are the two kind of things usually. Vaccines work in a different way. These are not vaccines, these are drugs. Okay, and then you want to find, so when we do drug design, we find molecules that bind to the protein and either makes it works more or work less. But we also want that small molecule to have other properties, and those other properties are everything from how easy it is to make it to not interact with other things in your body and do something bad. Okay? And you can think of this basically as a multi-object optimization. So you're looking for a molecule that will have some properties. So there are some objectives you want and some constraints. And the way to find these molecules is to look through chemistry. What are the molecules? And it's not easy to find those molecules. Okay? It's easy to find molecules that either don't bind to the protein, or if they bind to the protein, they bind to a lot of other proteins. So finding those molecules that bind to only the protein that you want and don't have a lot of side effects. If you think of the Venn diagram of that overlap between the two circles is quite small. And you need to look at very large circles to find that. So we were sitting there and saying, how do we find those molecules? What technology can help us to find those molecules? And the technology that we are using is using quantum computers. Specifically, we're using a quantum annealer, which is a kind of a quantum computer that is very good at optimization problems. We use machine learning, but a bit differently. Yes.
I forgive my ignorance again, small brain.
Please.
I thought that quantum computers were mostly not real. Like they weren't there yet. I mean, I know they're like the next stage, right? Where there's all sorts of craziness that those bring to the table because they fundamentally change the way we do computers. But I thought they were mostly science fiction at this point. You're saying you guys use them and this is a thing?
So they're not science fiction. They're most of the quantum computers today work, but they're very small. They have less than 100 qubits. Think about what kind of codes you can write with 100 bits. That's what you can do there. You can do some simple problems only. But there is one kind of quantum computers and can solve only a single kind of problems. Okay, and that's quantum annealers. A company like D-Wave has a quantum annealer, and it can only solve optimization problem. It's very good at solving the backpack problem, the traveling salesman. It's not good at anything else. It cannot do anything else. It cannot do hello world. It cannot do factoring of numbers. It can only solve one kind of problem. Think about GPUs, even more limited than GPUs. One kind of problems. So if you have a problem that you can rewrite in a certain format, it can solve it for you faster than any other system. But only if you can take your problem and reformulate it there. That's what we do. We reformulate chemistry into the language of quantum computers, into QUBOs specifically, which is the algorithm that we're using.
So, and the ones I've read about, the idea is a regular computer does zeros and ones, so it's binary, right? That's what all of our computers run on right now, on and off. And there are many theories of how quantum computers work, which, because from what I understand, the science fiction version is there are 32 states of an electron. Therefore, you could have, instead of zeros and ones, you could have 0 to 32 different versions of it, which would be stupidly powerful. The ones that I've heard of and read about that are real, and I'm using air quotes there because in my mind they don't do anything, but I'm wrong, obviously. They do 3, right? Is they have 3 states? That's the qubit, isn't it?
Or no, so they do. Okay, again, the quantum computers like the gate computers that IBM or Google or IonQ or Atom, they can do stuff, but it's really small systems. So if you are thinking, what can I do with those today? The answer is not a lot. What can you do with them in 5 years? If the engineers will solve all their problems, right? Of course, we always blame the engineer.
Sure. Well, that's always what I do. I blame the designers.
I blame the devs.
Yep. Each one blames a different group, but if they can do that, then we will be able to solve many problems that today takes really long time. They take so long that you cannot solve it because of that. Mm-hmm. Quantum computers, there is, again, the D-Wave, the annealers can solve one kind of problem, and they are very good at it.
So how did you get to the point where, I have lots of questions here.
Yeah.
Not to nerd out too hard on the quantum stuff, that's just fascinating, but how did you get to the point where I'm good at chemistry, I want to do things, let's do quantum computers? Like, that seems like a big jump.
So we did a whole lot of searching, a whole lot of thinking. We had other options as well, and we were also a bit lucky. We got introduced to a company called Fujitsu, who have a kind of a quantum computer, and they were looking for test cases. So our first proof of concept was sitting and talking with them. We've tried other things. They did not work very well. We did try the machine learning route, which we found, especially here for chemistry, I think there's not enough information out there. There might be companies that have those information, enough of it, but public knowledge, there's not enough. What you can get from public databases, it's definitely not enough.
So who is your customer?
I have 2 kinds of customers. I have customers that come to me and say, we have a difficult problem, design a drug for us. So these are partners. They tell us everything, what's their protein, what's their disease, what the constraints, what their objective. These are usually small and mid-sized biotechs that have a problem that they cannot, or that it's difficult for them to solve, and they come for us for that. That's one kind of customers. We are also developing now a SaaS product, and that's going to be a very different set of customers. If the biotech customers have 1 to 3 projects per year, the SaaS products make much more sense for bigger companies, pharma, that have maybe 10 projects per year, but they don't want us to touch their data. They don't want us to know what their targets are, what their molecule, the outcome of their molecule are, any of those things. So this is much more as a SaaS product, okay? They come into a website, they submit their queries, it goes in the background, they come back tomorrow morning and they get the results. The accuracy of their results is not as good. They get maybe 10,000 molecules. When we work with biotechs, with small companies, they get 20 to 50 molecules. It's much closer to what they need to do the next steps. Pharma companies get much bigger chemical space, but they can take it in there internally and find the best ones in there. So these are 2 different levels of complexity of answers, 2 different levels of engagement with us specifically.
Wow. Okay. So what made you guys choose? I mean, you're making molecules, which means you could, in theory, make anything, right? That's what we're all made of, as molecules, right?
Yes.
So what made you go drugs as opposed to plastics or energy or anything else, materials?
So this is where our own expertise came in. We are drug designers. We worked with biotechs before. We knew the market. We knew when you come to me and say, what is a drug? I know what's a drug. I know how to design drugs. I know how to be a seller in a drug market. So that's there's a technology, right? But there's our knowledge, our experts' knowledge. And that's we took a problem and we find a solution to it using a certain technology.
This seems like a very specific business model for a very specific group of clientele. So I'm guessing you already kind of had a client or targets for clients when you were coming up with this idea. And then did you reach out to them, or did they know what you were doing and say, I can't wait until you guys get set up and we're going to come to you with our questions? Or, I mean, how do you market or try to reach more available clients with something this specific?
So it's not as unique. So yeah, there's not millions of customers out there, but there are a couple of thousand maybe. And if you say I'm not just looking in the US, I'm looking all over the world, because biotechs you can find all over the world. That's the market. There are marketplaces. So, and these are usually more of a partnering conferences. So there's a partnering conference, everybody goes to it, and you say, this is what I'm selling. This is the kind of customers I'm looking for. But the customers come in and say, this is my problem right now. And they can come and say, I'm looking for somebody to design my molecules. And they can also come in and say, I'm looking for somebody who can test this, or somebody who can give me this kind of service. Okay, so there are many services. When we design, it's not enough to design the drugs, you have to test them before you can go to the FDA and say, I want now to test these molecules in people. You have to do many tests before that. So there's a very large marketplace of things that can happen before a molecule become a drug, and before the FDA will let you try it on people.
So it seems like this is already an existing network that you just, once you get in, you're in and you're kind of connected with everybody in the same space already.
Yes, so there's several marketplaces like that, or several conferences that you can go to, and yeah, there are how you market to in those places. It's not, we always learn. I started as a scientist. And if anything I've learned in the last 3 years is how to be the business side of things, right? How to be the CEO, so how to find customers, how to find the investors, how to find team members, everything else, right? How to build a company, how to make it a company that will continue to be successful. Yeah, and customers is definitely one of the most important things.
Well, you're leading right into a question I have, and that's where you're in a classic situation where you have two technicians starting a business.
Yes.
Neither of you are businessy people. You got the two nerds, right? And how, and you already touched on this, but how do you go from two nerds who are really good at what you do, clearly, to running a business? Like, that's a very different skill set.
And we mean nerds in a very loving way.
Oh yeah, yeah.
Yeah, okay.
I'm a proud nerd here, completely. And
Just for anybody
most
else
of
listening, didn't want to think
no,
that.
everybody in Polaris is a nerd because we geeked out on technology. We geeked out on solving technological problems, biological problems. But yeah. So how do you do that? I think people who are nerds love to learn. Okay, we're learning. We are good at learning. That's what we do, right? That's part of being a nerd. You're learning, and this is just learning other things. And we learned a lot. We have really good advisors. We are in a good area. Okay, we are in the Research Triangle Park in North Carolina, so there's a lot of people around us who are the combination of nerds and also involved on the business side of things. We are in a good environment, so the American Underground, and we just sat down and learned. We read a lot. We talked with people all the time and continue to do that. We listened to our customers. We listened to the people who said no. Many people say no all the time. You have to listen to them as well, as much as you have to listen to the people who say yes, right? Why would somebody say no to you? I mean, I bring them the most technologically advanced solution that they will ever see. Why would they say no? And when you talk with them, you understand how to make your process better, your sales process better, your product better. Okay, so you learn both from the yes and the no. You almost learn more from the no.
It's really interesting. I mean, this is like a mini master class on how do you go from technician to running a business, because a lot of people who are just pure techs, regardless of what they're into, they get paralyzed by the social / businessy side because they're like, well, I don't like people, right? That's common in nerd circles. I don't want to talk to people. I need to find and partner with someone who will be that front. But it seems like you guys just said, well, everything's a problem, so I'm going to solve it like I do every other problem and just learn and learn through it and get over my own predilections for being quiet or not being around people or whatever. And that's just a really fascinating, unusual way of hearing it. Most people are, once there's a problem, they're either going to find someone to do it for them or they're going to realize they can't do it and find a workaround. And you guys are like, no, we're just going to learn how to do it. And that's really interesting.
But also there's another thing here, right? If you go and maybe 30 years ago, okay, there was only one way of doing things, right? When you sold something, it was almost the used salesman kind of things, right? Today you can find ways to do things that are more in tune with who you are, right? So when I go and I talk about what we do in Polaris, I talk about technology. I connect with people through their problems, through how to solve their problems, through our technology. you need to find how you solve their problem. Are you solve when I say, you know, I wanted to learn how to be a better seller of what we do. The answer to that was to find other people who are selling for technology that are like me, right? I cannot go into a room, stand on the table and say, listen up, guys. That's not who I am. But when I sit and talk with people, I am much better at that. So you need to find how to do the things that you're not comfortable with, using your own, you know, your own, what you are, right? How you sell, how you manage, how you talk about the things you do, using your own strength. Each one of us can talk about the things they love, right? Even the most introvert, you find what she likes to talk about, and she will talk with you, and you can connect, and you can maybe solve a problem together, right? Because by the end of the day, you solve a problem. Nobody's going to buy anything from me if I'm not solving their problem. So you just need to find how you do it, how you yourself can solve it.
That's an interesting take. Yeah, a lot of times people will say, you know, you have to learn your limitations and then get someone else to do it for you. And it sounds like what you're saying is when you reach those limitations, instead of trying to adapt to the situation, you kind of let the situation adapt to you and meet you on your own terms. And this kind of leads us into our question that we ask everybody that joins us on the show. What are your top 3 pieces of advice for any entrepreneur or new business when they're starting up?
So 3 things. The first one is, when you have a problem, right? You can look vertically. You can look at your competitors, your customers, other people in your area. But you should always also look horizontally. What other people are doing that got nothing to do with you, but maybe solved your problem, right? If, you know, ChatGPT didn't start at ChatGPT, they probably took something from somebody who did something at vision, right? Or different kind of machine learning. So you don't look just horizontal. Sorry, don't like just vertical. Look horizontal. We are all individuals, of course, but at the end of the day, in many cases, somebody have had your problem and had a different problem, and you can use that technology to solve your problem. Always look outside. That's one. The second one is, the answer is always personal. How you sell, how you buy, how you develop something. These are people, and you need to always connect with the person that you're talking with, and then you can solve a problem, sell something, buy something. It's always personal. And the third thing is going back to what we talked about, right? You need to identify your strength and your weaknesses, and either change the situation for you so that your weaknesses become your strength, or you find people that complement you. Okay? I can write some code. I'm not great at it. I probably am not amazing at it. I have people that are amazing at writing code, right? So you need to find what you do, find what your strengths, find what your weaknesses are, find people who complement you, and that you enjoy working with them. Because again, at the end of the day, everything is personal. You will work with these people. You need to like them. You need to enjoy working with them.
I like the everything is personal take, because even as much as people will say, well, it's business, not personal, at the end of the day, a decision was made, and that decision came from a personal place. So,
Yep.
yeah, I
Always
like that.
personal.
Man, this is This is fascinating stuff. I apologize to everyone who's not a nerd. This is probably like we went way too far in the weeds, but I just can't help it. That's just good stuff. But I want to thank you for joining us so very, very much. This was a lot of fun. If anyone wants to learn more about you or Polaris, how would they do that?
So they will go to our website, www.POLARISqb.com. They will connect with me through LinkedIn. So I'm Shahar Keinan. You can connect with me or through the Polaris website or directly from me. Okay. And I usually try to answer emails. I try to.
You seem like you're probably way too busy to answer emails, but
No. It's amazing how personal, right? What kind of interesting people you meet and you talk with. So yeah, please.
well, we will include those links in our show notes, and they'll be underneath this video on YouTube too. So if anybody does want to reach out, you could just look below the video or check out the description in any of the podcast channels, and you'll find those links as well.
And thank you very much, guys, for inviting me. It was a pleasure talking with you and nerding together.
Yeah, very interesting. Very interesting part of this thing you do with the quantum computing. I'm going to have to look into that more. I know David's going to start researching that a little bit more now.
That's what we need to start programming for them. Let's do websites on a quantum computer. Let's do it. I don't think that's going to work, but that's okay.
We just published a white paper on a really, I'm not going to say simple problem, but a simplified problem of how you choose a menu item, right? A chicken and waffle, these kind of restaurants, you have to choose one chicken from many kinds of chicken, one waffle from many kinds of waffle. So this is an optimization problem.
That's
Very cool.
crazy.
Mm-hmm.
Gary, if people want to get in touch with us, how would they do that?
They can email us as well, hello@thebigpixel.net, or they can reach out to us on any one of our social media channels. We're on all of them. And those links are also below this video and in the show notes.
Well, thank you all for joining us once again, and we look forward to next time. Thank you again.
Happy to be here.
Thank you, Shahar. It was a great conversation. We'll see you guys next week.